Hey everybody, back with another video. Going to look at some Atari Football boards today. So let's see here. Where do I want to start? First off, I have two boards sitting here. I had helped a friend, get an Atari Football, and I had already fixed a board. But because he's kind of like a neighbor, in the community, a couple boards came up, so I ended up picking some up in case I could fix them and his, broke or something. So this one, actually, I can't remember exactly where I got it from, but I obviously already fixed the edge connector somewhat, did a slight repair on that, as you can see right there. And the other thing is I picked up another board, and I don't know where I got this one, so I'm going to cover some of the differences. One is, I didn't even know this, but there are two versions of the board. One with ROMs like this. I mean, even though this is technically a PROM, it's a 9316. And these are, what are these? Oh, they're all 9316s. Yeah, 9316, 9316. So these are quote, programmable ROMs. And then this board over here actually has these 82S185s, which are almost like bipolar PROMs, but they're actually PROMs, I think. They're not like bipolar, they're not fused or anything like that. I don't believe so. 82S185, and there's 1, 2, 3, 4, 5, 6 of them versus 3 here. So these must hold double the capacity of these. So I thought that was interesting. And I don't know what the circuit differences are, but this board's set up that way. This one here has the same problem on the edge connector here, where obviously somebody just put some wire there to fix that trace, and that's not ideal. But to power these up on the bench, it's actually pretty easy. This is the Atari test connector, where they would typically, plug in a test harness for probably the cat box, I guess, or something like that. And basically you have ground over here. This is your ground rail right here. And so I'm just going to hook up to ground right there and 5 volts here. Now, it's probably not ideal to do it this way, but it's easy. I could also hook up to this capacitor right here, ground on this side, and plus 5 volts. So this board only needs plus 5 volts to run. So it only needs plus 5 volts to get an image, and it puts out black and white composite video, which you can hook up to this resistor right here. If you look, it's right underneath the Atari logo. I'm not exactly sure what the resistor name is. I'll label it, but these boards aren't labeled anyway. So it's just, if you hook up onto that connector right here, there's a long trace that comes to this transistor. This transistor is from 5 volts. I guess it's bumping the video signal because it's got 5 volts on one side and it's got the composite video on the other, and then it outputs to this resistor here, and then from that resistor it goes to the video. So that's really all you need to get an image on the screen. But the other thing I wanted to cover on this video is this LM323, the way the 5 volts gets regulated is on the board, which is the LM323, but I don't have a power supply like the Atari Football does. There's like a big blue capacitor. I'll link to a couple other videos. I think the guy in North Carolina, I can't think of his name, he's a very popular YouTuber, but he did something on Atari Football doing the power supply. But basically it gets, from these two connectors, it gets 10 volts unregulated from basically the transformer and the filtering capacitor and a couple rectifier diodes on the power supply. Then it comes to here and gets regulated. So in this video I want to test how I can verify that without actually having the 10 volt power supply, is by using my ProTech 3003, even though that's regulated, is put 10 volts on here and verify this LM323 regulates it down. That's what I'm going to do. There's also a 4 ohm resistor here that drops probably the voltage on that as well. And you can see here it gets pretty burnt, so that resistor gets pretty hot. This one here is really hot. Look how bad the board is burnt. So I'm going to measure these resistors making sure they still are measuring the correct resistance as well. The other power supply that comes in is I think like 25 volts AC, and it gets rectified across these two rectifier diodes here, gets filtered through this big cap, and then 18 volts goes to this amplifier, and this 7812 voltage regulator regulates the 12 volts down to 12 volts for this LM324. So the only reason you need the 18 volts and the 12 volts is basically for the audio, which is the voltage is happening here, and this is the audio amp right there. Alright, so we're going to test those using the ProTech in this video, and we're also going to troubleshoot, make sure the boards work. So let's power it on board number 1. I'll be right back. Let's power this thing on and test board number 1. Here we go. Power it on. And I got my PVM set up for my component input, and let's underscan that. Yeah, the contrast is good. That's better. So obviously this board's working. Now the other thing is, you can, without a harness, you can test for do the test switch. Which resistor is it? It is this second resistor right here. If you can see that. I don't know which resistor that is off the top of my head. I already looked it up. And if you just ground that, we should go into test mode. Okay, and it says ROM OK, RAM OK, ROM OK B. I don't know exactly what the B means. It says ROM OK, RAM OK that way as well. And my graphics look good. I mean, I don't have the trackball. If I had the trackball, I'd be able to move this around. But I believe this is what a good working board is supposed to look like. So I think we're okay with this board. So board number 1 seems to be working. I don't know about the voltage regulator and the audio and stuff like that, so I am going to have to do some wiring on that. But before we do that, let's hook up this board and see what we get. Alright, this is board number 2 with the older style ROMs, 82S 185s. I'll look that up and figure out exactly what they're called. I don't think they're bipolar ROMs. They're just programmable ROMs, but they come in that smaller package. So let's power this thing on. Now, and this is what we're getting here. Some craziness. Now it does, I know it's going to be hard to see, but I see letters and stuff on here like game over or something, but obviously it doesn't look like there's sync, but my PVM showed that there was sync. Let me see. See, there's no sync. And then obviously it goes away, so I would assume that the PVM has sync. Let's go ahead and go into test mode. And that's kind of what we get. Just stuff going all over the place. So it still seems like there's a sync issue, even though the PVM is showing sync. So what's great about this is the manual for this thing is awesome. Yeah, hopefully you can see this okay. The manual is just awesome. I always like to work backwards. So obviously we have the video out. There's the transistor and that resistor that I'm hooking onto. So R26 is what I'm hooking onto. On one side is ground and one side is the video out. So I'm hooking on the side with the video out, obviously not the ground. So R26, 470 ohm resistor, and we have some signal, so we know something's getting there. So we come back to this transistor, and it's getting fed composite sync from K7, which is a 7402 or 74LS02, and that's where our H sync and V sync are coming in. We also, that's getting combined with a whatever signal this is. Oh, probably the V blank signal, I guess. Right? It's got to be. I'd have to look up the 7474 chip to see, but I would assume that's the V blank. No. What would that be? Scroll gate. Oh, that's just the video signal. You got two different video signals that are coming in, being combined with the sync signal, obviously, to get your composite video. So you have your one video signal here, one video signal there, all being combined into this transistor and put out. So let's just go backwards and start looking at the sync, because that's what we think is the issue. We're definitely getting images on the screen, whether they be, alphanumeric characters. It says from the scroll field generator, scroll gate. Yeah, so the playfield scroll, whatever this is, got to be the video coming from the playfield, and then the alphanumeric characters and stuff getting combined with a sync. So let's look at the sync. All right, I have the scope on, set to frequency, and we're going to go to, this is the chip in question, K7, and we want to look at pin 8, which is our vertical sync. And we have a good 60 hertz signal, 59.86. And then if we come to pin 9, that is our horizontal sync. And that obviously does not look good. I should have 15.7 kilohertz there. So something is going on with our horizontal sync. And it could be this chip, or it could be, backwards. I need to trace that back. Where's that signal coming from? And maybe this chip was even replaced. But I think we have our issue, or we're on to something here, this H7. That doesn't look good, but our vertical sync does look good. So our composite sync is getting jacked up. So we need to go find where H-sync goes back to and see where, if it's broken, if the trace is broken or something. Like I said, this manual is awesome. Basically, it tells you that the 12 megahertz crystal creates a 12 megahertz clock, and you should be able to measure that at pin 2 of N4. I don't know exactly how to measure this cycle time with my scope. I'm sure somebody will tell me, but I need to study that. P2 of N4. Let's look at P2, pin 2 of N4. N4. Here is N4 right here. Pin 2. And I have a good 12 megahertz clock right there. Nice and stable. So we know that's good. Then it says it goes, gets divided down by P5, P6, N6, all, and the last one. Now I could measure this whole chain, but it says to give a horizontal line frequency at 15.7 kilohertz, right? And the last signal is 256H at pin 13 of N6. Pin 13 of N6. Where's my N? Right here. N6, pin 13, 9, 10, 11, 12, 13. We have our 15.7 kilohertz. So basically we know our counter chain is working right. And then it generates the H blank and H sync signals coming off of N5. See figure 311, which is right here. And right there is N5. So we're looking for H sync on pin 9 of N5. Should be our horizontal sync. and our H blank is obviously off of N5 pin 6. So N5 pin 9, N5 pin 9, N5. Here is N pin 9. 1, 2, 3, 4, 5, 6, 7. And I have good 15.7 kilohertz. That is N pin 9. So that H sync, something's going on between that and our previous chip, which was what? Something else. Alright, I can see that on this chip here that I marked, this is a N5. Basically, there was some work done. I think this chip was replaced or something, or the traces don't look great. Like, even this one doesn't look great. But I ohmed out this. I ohmed it out from here to there. 7K7 pin 9 and N5 pin 9. Yeah. And there's no continuity there. So one thing I can do is just jumper that real quick. Jumpered. We'll power it on real quick. Alright, and we have this image. Now we do have some alphanumeric character issues, but the game is at least legible now. Let's go ahead and try our grounder test. It says ROM okay and RAM okay, but we still have some character generation issues. So basically I need to check all this work that was previously done. I might even remove those chips. I'm not sure, because it looks pretty ugly. But that's our issue with our sync, at least. And now we got some other issue. Alright, so still same situation here. You got crazy characters going on over here. I came to the alphanumeric generator circuit, and basically it does the manual is awesome on this, but it tells you that it's using this N2 and M2 RAM, which is right here, this working RAM here. But it says RAM is okay, and it could be the RAM, I don't know, but it does say that it's okay. And then I was just looking at this circuit, looking at the output. So obviously 1V, what is that? Is it an or an and? I don't know, but whatever. I was just basically looking at the outputs here of M8, 3, 6, and 8. That all looked good. Looked at the inputs of this latch at actually it doesn't tell you where that is, but it's actually this 74S 374 at, what is that, M7. So that's actually M7. I'm going to put a little mark there. It's my manual. M7, okay? And look at the outputs, and those outputs seemed okay, and that comes to this PROM at N7, which is right here. And I was just looking at, again, inputs and outputs, everything. I have activity on everything. Nothing was standing out, like jumping out. So I stopped at that at that PROM right there at N7, and then went down here to the H blank 256H going into K7, and I got to N9 and 2H, which should be, let's see, it's a 6 megahertz clock, and it's half at 1H, which is 3 megahertz, and then 2H should be 1.5 megahertz coming in at N9 pin 13. N9 pin 13, and that did not look right to me. So N9 is right here, pin 13, 1, 2, 3, 4, 5, 6, 7, okay, that's pin 13. Is that N9? Yeah. That's not 1.5 megahertz. I don't. N9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Pin 2 looks good, I think. Whoops. Pin 2 is 3 megahertz, as you can see there. I've got my scope right there. But yeah, pin 13, which is supposed to be 2H, is not good. So I need to track that down. Where's that 2H come from? 2H is P5 is where it first gets, have in the counter chain right there. So P5 pin 12, P5 pin 12. This is P5 pin 12. Is that 1, 2, 3, 4, 5, 6, 7, 8, 16, 15, 14, 13, 12. 1.5 megahertz. That looks good. That 2H goes to P7 pin 9. P7 pin 9. P7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, we got a problem. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so let me figure out what's in between there. So obviously there's a broken trace or something's going on between those two. And it looks like there was some work done on this chip as well, because this is the other one that I had some work done on. So let me check that, or jumper it. Okay, because I'm working with one hand on the camera, I can't show you ohming this out, but basically there's no continuity between N9 pin. Oh, is this supposed to be pin 13? Whoops. 15, no, 16, 15, 14, 13. Maybe I did the wrong one. Alright, I just double checked everything. I got it right. P5, whatever. Jumper that, and it's good. That looks perfect. Let's ground our test real quick. So I think we just have a couple jumpers to fix. ROM okay, RAM okay. That's it. Just some bad replacement work on these chips. I wish they would have socketed them. Maybe. I don't know. But there's a trace there I need to fix and a trace there I need to fix, which I need to go underneath to see. Alright, this is the underside of that P5 chip right here. And this is pin 12. Let me see if I can. Right here. 9, 10, 11, 12. And there's a break somewhere right there, I think. Because it should come over to this spot right there. But no continuity. I did a ohm test on it. So I'm going to do a jumper right there. And maybe touch up some of these. I don't know, they look... I'm scared to touch it because now I know it's wrong. I don't want to screw it up. The break is right here on the top side. It does look like there's continuity there, but that spot is bad. Right there. There was some damage. It looked like they tried to put some solder on it, but I will run a jumper real quick. A tiny one. Alright, I fixed that jumper there. I also cleaned up this other one that they had done. And fixed... I didn't actually have to do a jumper underneath. Let me turn this off, actually. I ended up doing a jumper here, but it's right... You can see that. Once I cleaned it up with some solder, the connection was there. Dang it. Let me get something to move that out of the way. You can see it kind of right. Hopefully you can see that without the glare. But anyway, there was a solid connection there, but I just didn't trust it. The fact that I just cleaned it up with some Brain fart. The fact that I cleaned it up with some flux and it fixed the broken trace. But see, there's a few other ones like right here that it looks like they were repaired somewhat just by dragging some solder on there. Who knows? Let me know what you guys would do. I'm not going to go through and fix things that are working, but it's obviously not great looking underneath of here. But I did put a jumper in for just in case that one wears out or something bad happens to it.